The fact that we can help these delicate and sensitive electronics survive a rocket blast, it's like a train wreck happening. The rocket launch is really a controlled explosion.
9. Ignition sequence start.
These electronics are quite often very fragile and they need to perform or the rocket doesn't go where it's supposed to. So our vibration isolation mounts absorb a lot of that energy to protect the electronics so they can do their job. There are some digital computers that control basically the brains of the rocket. There's guidance units on there that are very critical. In many cases with these electronics boxes, they are originally designed for a much less severe environment than strapping them onto a rocket, and they have to figure out how to make them work. We have to protect these electronics through that environment. And the fact that they survive, number one, is a huge milestone to achieve because these are vibration levels unlike anything you see anywhere else. And the second part, I think, is our materials. It's key that quite often they do have to function once they're up in space. What the engineers were able to accomplish back in that era, without digital computers for doing their calculations. A lot of this was hand calculations, work with slide rules, and never really imagined that I'd be working for a company that provides solutions for such critical components that even go into space. That's a really cool thing.
Beautiful, just beautiful.